Hello, 8th graders. Today we are going to go over Chapter 3 in our Coda's Earth, Moon, Sun iBook. Chapter 3 is about seasons. Okay, so we've already talked about rotation and revolution and how the Earth moves around on its own axis, and then also how it moves on its path around the Sun. And the motions of Earth, those two things create, along with Earth's tilt, they create our seasons. Okay, so let me scroll up to Chapter 3. You guys in elementary school probably, or maybe even before, learned some of the basics about seasons. You know what to look for in each season. You know how to dress for each season. You know what you're going to see or different activities that are involved with each season. And here in Little Falls, our latitude, meaning our Earth is broken up on these little lines. Okay, here's the equator. The equator is at 0 degrees. Here's the Tropic of Cancer at 23.5 degrees. And then here would be the North Pole at 90 degrees. Well, Little Falls is right about 45 degrees north of the equator. So it's right in between the equator and the North Pole. And for that reason, we have really defined seasons, 4 very definite seasons. Now, if you move up from the middle towards the poles, you're going to have less of a change from season to season, right? There's going to be warmer times than others during the year, but it's going to be like cold and then not as cold, right? Down here at the equator, opposite is true. You still have 4 seasons, but there's not as much of a change in the temperature between seasons. There's hot, really stinking hot in the summertime, and then not quite so hot in the winter time. Or yeah, not quite so hot in the winter time. 45 degrees, we have a huge change in temperature. I mean, think of the hottest day in the summer. It can be 95 degrees, right? Think of the coldest day in the winter. It can be negative 45 degrees, right? 50 degrees with wind chill. All right, so we here at our latitude have a really big swing in temperatures from season to season. Okay, well, all of that is caused by Earth's tilt. We are not sitting straight up and down on our orbit. We've got an axis, an imaginary line that goes from the South Pole to the North Pole. And if we were cruising around the sun straight up, we wouldn't have seasons. We would have local things that happen from day to day to change things up a little bit. But throughout the year, our temperature would be kind of like how it is in fall and maybe a little bit cooler year round. But because our axis is tilted 23.5 degrees, we have different angles of sunlight throughout the year. Okay, so one of the common misconceptions is that the sun is closer to Earth in the summer and farther away from it during the winter, and that's why we have such different temperatures. That's not true. It is caused by the tilt of the Earth's axis of rotation relative to its plane of orbit around the sun. Okay, so I have hang on a second, I have a diagram here that I drew. Okay, so I've got the Earth in 4 different positions. Okay, notice that in all 4 positions, the tilt is the same, right? We're always tilted at 23.5 degrees. We don't bobble back and forth and change our tilt throughout our trip around the sun. We are always tilted in the same direction as we move around the sun, and we rotate counterclockwise and we revolve counterclockwise, okay? So again, one of the misconceptions is that we are closer to the sun in the summer. Well, that's not true, okay? If you look at us here in the summertime, here's our tilt, here's the equator, the northern hemisphere is tilted towards the sun, okay? And so that gives us a better angle of sunlight. We get a more direct shot of sunlight, okay? As we cruise around the sun, it kind of equals out here, and so we get daylight, equal daylight and nighttime. And as we cruise over here to this side, we are going to be tilted away from the sun, receiving the least amount of sunlight. And it's not just the hours of sunlight, it's also the angle at which the sun hits us. Okay, so think about a candle. Picture this Sharpie as a candle. If I hold my hand right over the candle is going to burn my hand, right? It's going to burn my hand because it's a direct shot. If I angle my hand, I am not going to get as much heat energy. If I angle it even more, I'm going to receive even less energy. Okay, it's the same thing with the Earth. If we've got sunlight hitting us a direct shot like this, we are going to receive a lot of heat, which is why the equator has a warmer climate, right? When the Earth is tilted away from the sun, that sunlight can glance off of it, and we don't have as intense warming as we do in the summertime when the northern hemisphere is tilted towards the sun. Okay, it says during the summer, areas north of the equator experience longer days and shorter nights. In the southern hemisphere, the sun is as far away as it will be, and so it is winter. Locations will have longer nights and shorter days, and the opposite occurs in our northern hemisphere winter on December 21st. Okay, so we talked a little bit about in December, on December 21st, we talked about how that was the winter solstice, right? The winter solstice, let me make this big here. The winter solstice happens when we are actually closest to the sun. Okay, this location right here is called our perihelion, and we are actually closest to the sun on this year. It was on January 2nd. Okay, our winter solstice occurred on December 21st, 2020. Okay, so at this point in our orbit, we were tilted away from the sun, and so the sun is just glancing off of our latitude right here. In this case, the southern hemisphere is pointed towards the sun. So in the southern hemisphere, they're having their summer when we're having our winter. They have summer during Christmas, and they have winter during our 4th of July. Not that 4th of July really matters in the southern hemisphere. All right, so that happens in December. Winter solstice happens in December. And that is a day where we have the least amount of sunlight, right? We've got like 8 hours of sunlight, and the rest is dark. After that day, after the 21st of December, we have began to gain moments of daylight. Okay, so as we cruise around here, we keep gaining and gaining and gaining and gaining some sunlight until we get to what's called the vernal equinox. The vernal equinox happens on March 20th. Equinox means equal. Okay, so at this point in our trip around the sun, it's kind of like a road sign that we get to in March. We are going to have 12 hours of daylight and 12 hours of nighttime. Okay, we continue still gaining, still gaining, still gaining, still gaining until we get to our summer solstice. And our summer solstice this year happens on June 20th. That is the longest day of the year. So we have only about 8 hours of nighttime and the rest is daytime. That's those great summer nights where the sun is setting at like 10 o'clock at night almost, and it's still light out at 10. All right, notice here that northern hemisphere is tilted towards the sun. Also notice here, we are farthest away from the sun that we ever get. This is called our aphelion. Okay, so it's another road sign on our trip, a marker where we are as far away from the sun as we ever get, and it's our summertime. The aphelion, or the point at which we are farthest away, is on July 5th. Okay, so how can that be that summertime happens when we are farthest away? Well, the distance is so great that it has nothing to do with distance anymore. It's kind of like if we were in my classroom at school and we had a campfire that was out on the football field. Could we warm our hands on it from my classroom? No. Well, what if we walked to the loading dock of the school? Could we then? No, it's still too far away. So it doesn't have anything to do with the distance. It has everything to do with the angle at which the sunlight is hitting our particular line of latitude, okay? So again, our winter in the northern hemisphere is when we are actually closest to the sun, but our northern hemisphere is tilted away. And because of that, again with the candle, right? Our hand is angled way back. We're not receiving as much sunlight. Over here, when we are farthest away from the sun, the Earth is tilted, or the northern hemisphere is tilted towards the sun. Okay, so we're increasing that angle, and we are getting a more direct shot of sunlight. Okay, let me go back to the chapter here. There's a couple diagrams here that show just that. It shows that here would be our 90 to, if we were straight up and down, but we are tilted 23 degrees. Okay, so different part of the Earth receive different amounts of solar radiation. Which part of the planet receives the most solar radiation year round? What do you think? Looking at this diagram here, which is upside down. Okay, if the sun is shining right here, throughout the year, the area on Earth that is going to receive the most direct shot of sunlight throughout the year, no matter what the season is going to be areas along the equator. And that's why the equator, those areas are so warm year round. That's why people here in the northern hemisphere flock down to the equator or near the equator. We go south, right? Because the further we go south, the more direct sunlight we are getting in the winter time. All right. Different areas also receive different amounts of sunlight in different seasons. What causes the seasons? Well, that is a big picture question that I swear I will ask on a test, right? And the state of Minnesota will also ask you that when you take your MCAs. What causes the seasons? Say it with me. The tilt. True or false? Our distance from the sun causes the seasons. False. It's not the distance. What is it? Yes. It's the tilt. All right. Northern hemisphere summer. The North Pole is tilted towards the sun, and the sun's rays strike the northern hemisphere more directly in the summer. More directly in the summertime, right? We get more of a direct hit in the northern hemisphere when we are tilted towards the sun. On June 21st or 22nd, and actually this year it is on June 20th, the sun's rays hit the Earth most directly along the Tropic of Cancer, which is at 23.5 degrees north, okay? So that's right in the middle here, 23.5 degrees, all right? So they get the most sunlight, and that is what we are closest to, and so we are also getting the most sunlight. Winter solstice in the northern hemisphere happens at or around December 21st or 2nd. The tilt of the Earth's axis points away from the sun during that, okay? So we are tilted away from the sun. We are getting the sunlight, or the radiation, is kind of glancing off of our line of latitude, and we do not receive as much solar radiation. We do not receive as much heat. And the opposite is true, okay? So when it's summer for us, it's winter down south in the southern hemisphere, and vice versa. Okay, we don't hear about that a lot. We don't hear about people having winter when we're having summer very often, because if you look at a globe, most of the density of population of humans is in the northern hemisphere. There's not, I mean, there's South America, but there's not very many places in the southern hemisphere where people live that that actually have our same line of latitude in the southern hemisphere. Okay, so last part here, halfway between these two, we have autumn and spring. And again, these two areas, the vernal equinox and the autumnal equinox, those are days where we receive 12 hours of daylight and 12 hours of nighttime. Okay? I am going to post a little video that goes along with this and a question, and I will talk to you soon.